Hi everyone. So today I am planning to discuss connected and autonomous vehicles in more details. I will talk about connected vehicles, autonomous vehicles or automated vehicles, and then we will talk about connected and autonomous vehicles. So first, let's discuss connected vehicles. A connected vehicle refers to a vehicle that is equipped with advanced technology or communication technologies. So these communication technologies allow allow the vehicle to exchange information with other vehicles. For instance, if a vehicle is trying to communicate with other vehicles in a network, transportation network, they can communicate using either dedicated short range communication or cellular communication. So cellular, it can be 4G or 5G, but the main way of communication for cellular is 5G, which is going to be faster and it's going to be much less latency. So on top of communication with other vehicles, a connected vehicle, as you can see in this figure, it can communicate with traffic sign, it can communicate with infrastructure, and also it can communicate with surrounding environments. For instance, we can have some sort of cameras in this traffic light to look on different directions, and it's going to send these safety messages to a connected vehicle. So the primary uh, use of connected vehicle is to improve the safety. So that is really important to know about it. So there's a video here. So I would suggest you to take a look at this video. It's discussing in general connected vehicles, and it gives some examples about safety, how it's going to improve the safety. For instance, using connected vehicle technology, if a car is approaching an intersection and there is another car is coming from another side of the intersection, so the connectivity allows them to communicate with each other to avoid collision. Or let's say if there is a two-lane highway and two cars that are drive like a car is trying to pass a car front of it, so it can give some alarm and messages in order to avoid collisions. So take a look at this video. This is an interesting video and it's discussing connected vehicles in general, like vehicle to vehicle communication and so on. So before talking about connected vehicles, let's discuss what is a traffic management system. Why we want to know about traffic management system? Because traffic management system is really essential for congestions and other aspects like monitor traffic. It can do analyze the traffic data. It can do control of traffic, and it does also incident management. So a traffic management system is a comprehensive set of technologies, strategies, and infrastructure designed to monitor, control, and optimize the flow of traffic on roadways. And for instance, let's just talk about few options of the traffic management system. If there is an accident, so using this traffic TMS is going to ask the stakeholders and relevant personnel to respond to an emergency situations. Another main objective of TMS is Intelligent Transportation System or ITS integration. So traffic management systems are often integrated with broader intelligent transportation systems. And this integration allows for a seamless exchange of data and coordination between different components such as connected vehicles, smart traffic signals, and dynamic message signs. So ITS is going to help to make connectivity between those different components. For instance, a connected vehicle, as I said, traffic signals to coordinate the timing of traffic signals, and also dynamic message signs so you can send and receive information to connected vehicles for coordination, better coordinations, optimizations, and optimizing the overall objective of a transportation network. So let's discuss quickly vehicle-to-vehicle communication. So it refers to exchange of data from from two or more vehicles that they can communicate with each other. Usually, the V2V is happening through DSRC, which is dedicated short-range communication, or it can happen using cellular V2X that we call it cellular vehicle to everything. So CV2X is really is well known in V2V communication, and what they can be transferred or transmitted between vehicles to vehicles. For instance, their location, their speed, their braking patterns, and safety messages they can be transmitted. So V2V, one of the primary reasons for V2V, the same as connected vehicles, is improving the road safety. Usually the equipment for V2V, they allow communication over 300 meters and they can reduce number of crashes. So using V2V, we can reduce number of crashes. For instance, just looking at the data, 6.8 million police reported crashes resulted in 36,000 fatalities uh, and approximately 2.7 million injuries. So that's a lot of injuries and fatalities. So the good thing with connected vehicles or V2V communication is the fact that we can reduce this number of problems or injuries or accidents and crashes. So the other concept that we want to discuss quickly is vehicle to infrastructure communication. Vehicle to infrastructure communication refers to the exchange of data between a vehicle and surrounding infrastructure. For instance, a vehicle, it can communicate with a traffic sign to see what is the remaining red light, let's say, timing. Or it can also communicate with some of the safety infrastructure. They can send the information about the weather. It can send information about number of available parking spots, for instance. So in general, V2I, it can enhance the safety, efficiency, and effectiveness of transportation system. So as I said, it can also give some alarm and warning information through onboard through roadside units. So if you have a roadside unit and it can give weather information, it can give road hazardness and other relevant data to the vehicle in order to improve the safety, efficiency of transportation system. So some of the applications for V2I or vehicle to infrastructure are listed here. So one of them is traffic management. As I mentioned before, TMS, it can use this data in order to improve the efficiency. It can change the traffic signal timing, and it can send information for collision avoidance, and also it can improve the congestion in certain areas or traffic flow in certain areas using this information. Safety application, obviously for road construction, road zones, work zones, so you can send information to the vehicle in order to be aware of that ahead of time. Eco driving and energy efficiency is another applications that we usually use. For instance, when we want to approach a traffic sign, if we know how many seconds the red remains or how many seconds we have to pass, so we can manage to accelerate or brake a certain time in order to get through a traffic line, a traffic light. And also intelligent parking, that's another application of this type of V2I communication. For instance, we can get real-time parking availability information and nearest parking facilities with available spots. So the next topic we want to talk is V2X or vehicle to everything communication. So vehicle to everything communication refers to all different types of V2 uh, for instance, any other ways that a vehicle can communicate with surrounding environments. I discussed vehicle to vehicle already. So there is another one is vehicle to infrastructure. So the other type that a vehicle can communicate with other surrounding environment is with pedestrians or human. So that we call it V2P, and then to the servers is called V2N. So V2X is going to include all of those different communications. So now let's talk about autonomous vehicles. So I said connected vehicles are the one that they have connectivities and they are able to communicate with other vehicles, pedestrians, server, infrastructure. But autonomous vehicles in general, based on their definition, they are not connected. So they have different sensors or sensors in order to uh, make their driving like self-driving. So according to SAE, which is Society of Automotive Engineers, SAE is really like important. It's really like giving definitions for autonomous vehicles. So based on SAE, an autonomous vehicle is defined as a vehicle capable of performing all driving tasks under any condition or environment without requiring human intervention. So one thing I wanted to mention again, autonomous vehicle is different with automated vehicles and it's different with connected vehicles. So let's just be really cautious about their definitions because sometimes people they use them instead of each other. So SAE has also some sort of guideline for automation or level of automation. For instance, you can see here that there is no automation. We call it level 0 or basically 0. So it means zero autonomy. The driver performs all driving tasks. So the car that doesn't have any features, driving assistant features, automated features, like a really conventional old vehicles, that's 0, level 0. The other one is driver assistant, which vehicle is controlled by the driver but some driving assist features may be included in the vehicle design. For instance, it might have cruise control. So that is level 1 of autonomy. Most of our cars right now, they are level 1 because they have ABS, they have some lane keepers, they have some other features such as cruise control. The second level, so in general, before continuing with that, in general, we call and we say there are 5 levels of autonomy. Okay, so level 2 is a partial automation. Partial automation means that vehicle has combined automated functions like acceleration and steering, but the driver must remain engaged with the driving tasks and monitor the environment at all times. So that's level 2. Level 3 is conditional automation. So it means the driver is necessary, so we need to have a driver. The driver must be ready to take control of a vehicle at all times with notice. So for instance, a Tesla, I would not call it fully autonomous. I would call it, let's say, level 3 or level 2 and 3. So level 4 is high automation. The vehicle is capable of performing all driving functions under certain conditions. The driver may have to the option to control the vehicle. So there is an option for the driver to drive it, but it can drive by itself completely, like it's self-driving. And full automation is the vehicle is capable of performing all the functions. The driver may have the option to control the vehicle. So uh, level 5 is a full autonomy that vehicle is doing everything. So in general, to just add more about level 5, the vehicle can autonomously perform all driving tasks under any conditions or environment. But level 4, it says that the vehicle can perform all driving tasks within specific conditions and environments. So there are some limitations between level 4 and 5. So now let's talk about connected autonomous vehicles. So if a vehicle has connectivity, at the same time it's autonomous, we call it connected autonomous vehicles. So connected autonomous vehicles refers to a new generation of vehicles that combine both connected vehicle technology and autonomous driving capabilities. In general, connected autonomous vehicles are equipped with advanced communication systems that enable them to exchange data and information with other vehicles, infrastructure, pedestrian, and network devices in their surroundings. So, what are the things that connect autonomous field they should have? They should have 5G or connections, so it can be 5G cellular or DSRC. They have GPS. They have some onboard computing, like a GPUs, in order to process the data in real time. They have local mapping. They have proximity sensors, such as radar, lidar, camera, and some others. They have camera as well, and they have V2X, which is a connection between vehicles, which I already mentioned that. So here there are some definitions of that. For instance, GPS is really necessary to find the location, orientation, and speed of the vehicle. Onboard computing, I already mentioned that they are used to exchange like process data exchange between vehicles, and also process the sensor, lidar, and camera data. Proximity sensors are the lidar, ultrasonic, radar, and camera. We can still call it like proximity sensor, but it camera provides a 3D and color vision, capturing visual details that the LiDAR cannot. So allowing M2M or machine learning or machine learning algorithm to identify and understand various components of the environment, such as pedestrian, road marking, traffic signs, what's the speed limit, and other things related to that. So I'll stop here, and I hope you enjoy uh, the rest of this course.